I'd like to introduce Tal Kandel and Tzur here, who are going to be speaking about disrupting AI attacks early. They represent malanta.ai, one of the newest folks participating in AMTSO. Please give them a warm welcome.
Thank you very much. We didn't have the time to get to know everybody, and I understood that there are vendors and testers. Can you raise the hand just for me? Vendors. Testers. Vendors.
Neither.
No, you're the regulator.
Yeah.
So the fight will happen on the first floor? No, I'm kidding. Anyway, thank you very much for AMTSO for giving us the opportunity. Just a couple of words about who we are, because we are relatively young. We started the company almost a year and a few months ago. And basically, I'm a co-founder. We are 4 co-founders in the company. All of us come from the background of cybersecurity, 20 plus years. We did corporate, we did startups, we did exits. And now we're doing that. Some of us are coming from the offensive side, some of us coming from the defensive side. We are talking about a category that is called pre-attack prevention. This is what we are trying to solve. Prevent attacks before they start. This is very ambitious, I know, but that's what we are planning. And currently, as I said, we're very early stage. We're pre-revenue, but we have something like 15 different design partners across corporates and security vendors and governments that we work with. End of commercials. The talk that we wanted to bring, and the information is called Preempting the Machine. And basically, this is the base stuff of what we are doing. We do believe that a lot of the attacks today are leveraging AI, not necessarily to create payloads, but also in the very early stages of attacks, like recon and resource development. If you're thinking about the pre-attack framework of MITRE, this is the areas, this is the stages that we are talking in. Just a few ideas about what we call AI attackers. Basically, it's anything that leverages Gen AI, but also AI and machine learning algorithm. And let me remind you that it's been commoditized in the last 2 years, although also the algorithm itself and the compute power that you need in order to run. So definitely it's there. As I said, we are looking at the recon and resource development stages. And since these are basically AI agents that we are seeing out there, they are using a lot of time legit resources. And a lot of times we'll give a sample of what we think is an attack vector which is very, very old but being used heavily in the last year. They're almost getting back into known techniques from a lot of years back and just doing it very, very efficiently. Operations follow the attack group's architecture, as all of us pretty much aware of. So you will find, or we see the operations center from the attack perspective, and then the near servers and the far servers and jump servers and all the infrastructure. And this is basically what we're seeing. 2 other definitions for AI attackers. It's not about automation, it's about autonomy. So we definitely see sophisticated thinking or ways to understand what needs to be done, and then completely autonomous operations. And then, of course, scale. The end result is, when we are seeing these attacks and working with our design partners, is that the time in order to launch and create an attack infrastructure goes down from days, if we're talking about cyber criminal groups or even nation-state actors. It goes down from days to minutes. So think about all the way from targets. So the prompt will be target financial institution in Portugal. And from there, everything happened in minutes. And we'll try to show you a little bit of a demo about what that means in a second. Everybody in the past day, thank you for being on during the end of the conference, but we added some information just to give you, because you asked for use cases. This is a gambling network that we analyzed something like, I think, early this year.
Yeah, we've been monitoring this network for a few months now.
Yeah. And by the way, I'm a co-founder and I'm responsible for the go-to-market side. I have a cybersecurity background and engineering stuff, but Tzur is the smart guy, he's the cybersecurity analyst. So everything that needs to be validated, that's go through him, okay? Cool. So from a gambling network perspective, we're talking about all the attack vectors that are happening again. So we're talking about subdomain takeovers. And it sounds familiar what you were talking about. The network that we saw, think about it that the attack resource that is being used is a subdomain of legitimate companies. So dangling DNS, anyone remember that thing? So misconfigurations in DNS records that allow anyone else to take over that subdomain, and now it's being used as part of an attack infrastructure. So when we're thinking about indicators of compromise, there's almost no way that someone will point that to be an indicator of compromise because it belongs to someone, to a company, and it's completely legit. So those are the number, this is the distribution. The other thing, we might go with an official, not official, a public report about this network, but I choose to speak here because it's a very unique forum. But there are very cool techniques that are being used as part of this network, making it very, very difficult to understand exactly what you're doing, what they're doing, and it seems it's the gambling is only the facade. Underneath it, there is a lot more that is going on, but we might report that. So moving forward in this presentation, we'll show you a quick demo about what it looks like from an attack perspective. This is a simulated environment. This is not a real environment, but something that you will get an understanding about what we are seeing. And Tzur will take us through that.
So thank you very much, Tal. So what we can see in this demo, as Tal previously stated, is an AI attacker being able to utilize a very efficient example system of an attack against a company from the financial sector in Portugal. So as you can see, the attacker right here has several AI agents where each of them is basically utilized for a different purpose. So as you can see from the first and initial AI agent, this agent is basically responsible for the reconnaissance. This agent basically scans and performs autonomous, as previously stated, actions that allow the attacker to actually initiate and discover vulnerable assets, which in this case is, as Tal previously stated, an exposed dangling DNS record, which allows the attacker to automatically initiate a subdomain takeover using the AI agent, which not only just creates said resource, but also allows the attacker to automatically create the relevant phishing site, which, again, the efficiency and speed of said things that can happen in minutes is surprisingly quick and incredible and very hard to trace. And after creating the phishing site, another AI agent is basically capable of creating compelling phishing messages that can also be automated to send via WhatsApp, email, etc. And after that, basically, we have an additional AI agent which can collect, in fact, all the relevant access tokens and cookies that a user that enters the hijacked subdomain, in fact, actually initiates. And because in this specific example, we also have cookies that are basically defined to be effective for every subdomain under the main bank domain. So this allows the attacker, in fact, to hijack any relevant cookies and or access tokens that are configured that way, which is also like taking advantage of the legitimate website's configuration to allow it to, in fact, steal relevant IDs, access tokens, and send them to a C2 server, which, again, the configuration to send the relevant results and relevant private data from the hijacked subdomain to the command and control server is also automated and, again, configured using an AI agent that is specifically used by an attacker for said purpose. And we can see, again, that the phishing website created by the AI agent is also surprisingly very compelling and pretty much reminds of the original subdomain, which also makes the detection many times very hard to trace, as previously stated. And this whole process, its main strength is, again, the scalability, the easy way to basically create these whole things in minutes, as Tal previously stated, and receive all this data that the attacker can also then automate it to initiate it to a relevant database of credentials and perform additional attack vectors using harvested credentials from the main website.
And again, this is a simulated demo, but we saw indications of this presence out there. I will say that, again, a lot of organizations, a lot of companies are thinking subdomain is a DNS issue, or subdomain misconfiguration, or DNS misconfiguration is an issue for the networking team, the guy that manages the DNS, but eventually we've think about, and we simulated that as well, getting a WhatsApp message with a preview, it's a game over. It means that all the credentials that you have on your phone are now moving into this AI agent on the other side, right? So it's no longer a DNS misconfiguration. It's a complete takedown of the whole access tokens and all the thing. And again, think about it. The reason that it happens more in the last year is the commoditization of cloud services. Any company now uses cloud services. Any company and the cloud services itself are vulnerable. So if you go to Azure and tell them that they need to handle dangling DNSs and subdomain misconfigurations about their resources, they will say this is a shared responsibility model and it's your problem, right? And this is Azure. It's not Alibaba or anything else, right? Sorry for anyone else. So that's the reality. And again, this is one simulation of many that we are doing. So that's all up to here is about the problem, the way that we see it. And it's going to be even more severe as years go by. But that was a very great promo, and thank you for being before us. AI agents are doing mistakes, but the people that operate this infrastructure are also doing mistakes. What we found in the last year plus during our research and when we are building the systems that we'll show you a little bit how to mitigate that, or how we think that it should be mitigated, we are tracking about everything that is being done on the attack side. So from our perspective, in order to stop attacks before they start, you need to go all the way to the recon and resource development stage and understand what's going on there. And we'll show you what we think about IOCs and how IOCs need something in addition. But basically what we wanted to show here, this is a legitimate timeline of domain and resources acquisition by a legitimate company. We're using CyberArk because all of us came from CyberArk. Don't know if you know it. It's a kind of a security company just been acquired by Palo Alto. Thank you for ISUs, anyone that has some. So this is how it looks like during 10 years. You will see domain acquisition with every new project, every new branding campaign, every new something. And then the other dots are certificates and IP addresses that have been associated with those domains. And everything looks like something that you can understand. Anyone, anything to add?
So basically we can see legitimate infrastructure, as Tal previously stated, that shows us using our skills to basically allow us to create this timeline map that can show us in the next slide the difference between how a relevant legitimate infrastructure look compares to this relevant malicious infrastructure that is utilized by AI attackers. So this shows us that even with all automation and autonomous system, there's still a place for the attackers to get better, basically.
Yeah, so with all the new technology and GenAI, everything that AI agents can do, still the process of acquiring a domain needs to go through a registrar, still they need to associate the IP address, still they need to get the certificate from Let's Encrypt with no validation at all, but they do. And then that's from our perspective. Again, this is only one example about how we think about things, but this is currently the ideal place where you can actually catch them. Everything that they do around here doesn't include any maliciousness, right? There's no payloads. It's not weaponized by the way that a lot of the vendors here are trying to discover maliciousness. Because it's basically legitimate behavior of anyone. It's just you need to understand the association of who's doing what when. So a quick example. From our perspective, moving to how we tackle that and how we suggest to solve it is by shifting security left. I know we heard a lot about shifting left when we talk about DevOps and developer security and stuff like that. We think that that needs to be done also when we are talking about MITRE attack framework. Go all the way to recon and resource development, and let's start doing stuff over there. By the way, if you go into MITRE attack framework and you look at pre-attack resource development, the one single mitigation is pray. Or use recorded future if you really need to understand a little bit about threat intelligence and try to anticipate what is going to happen. But that's basically it. So, and we say you need, we can do better. So basically what we are doing and what we encourage others to do is to use AI agent to map the attack infrastructures because it's enormous. The scale is infinite. You need AI to help you with that. And then use AI agent to map the company's digital surface. So we are mapping the internet for the past 12 months. But once we have a customer or design partner, then we start mapping their digital surface. We do it the same way that AI agents on the attack side are doing it. So it's really, really quick. And the last thing is we are using AI algorithms in order to correlate between here's the targeted infrastructure that is pointed against you, here's what they're going to hit, and here's what you need to do in order to take it down. So that's the approach. And then we introduce something that we call indicators of pre-attack. So
or IOPA for short.
Sorry?
Or IOPA for short.
Or IOPA, which sounds jilly, I don't know. Anyway, indicators of pre-attack, that's what we called all the resources that we identified that belong to an attack infrastructure. And it looks like that. Clusters, galaxies. People use the term galaxies other than MISP. In MISP you can find galaxies, but it looks like galaxies. And basically what you see here are attack resources. So domain, URLs, IP addresses, SSL certificate, and coming up code repositories, because imagine that attackers are using code repos in order to automate everything and do it quicker because it works. And in our vision, there are also digital wallets and other things that attackers are using in terms of resources. The important stuff is how you associate between different groups of resources, and that will be the green stuff over there, which is, in this example, SSL certificate, which is a very strong connection because you have a lot of information on the SSL certificate, who created it, and who can be something, but as long as they have ID that is coming back, then you can do what you did, basically, in a way. Some examples, real-life examples, so you know that we are not just talking in theory. Back at the end of August, Checkpoint released a report about the zipline campaign, sophisticated phishing attack. Within the report, they included IOCs. In our world, we're taking IOCs, putting that into the machines, our machines, and we enrich those IOCs in addition with 160%, 24 additional domains and additional IP address that are part of this attack infrastructure. Now think about what customers and other entities can do when they have more view about the attack infrastructure, not just only about the things that are indicators of compromise. We call it soon to be malicious, because it's definitely 100% part of the same infrastructure. It's just a matter of when it will be weaponized and when they will use those resources. The next slide didn't exist in the presentation until the guys from Google showed up. And then I said, okay, let's put it there. We did a little benchmark against Aristotle and Google Threat Intelligence, which is the new merger of VT and Mandiant stuff. And basically, we took the top 20 or 25 attack groups. And what you see in red are things that are associated to, attributed to an attacker, an actor, and malicious. And then the yellow stuff is indicators that we found that were not attributed in VirusTotal, and we managed to attribute it to that actor. And in green, you see stuff that Google in general, VT and Mandiant, didn't know that are malicious, and we did. So that's enrichment. And the last example, we only started, again, the data exists since end of June, when we included some of the models. And basically what we are seeing that in this example, the average lead time is 74 days from the moment that we identify an indicator of pre-attack until the time it turns into an indicator of compromise, which means that it's being identified as malicious. And again, VT is currently what we're using for benchmark.
And also, I would like to also point out that in addition to the data that was spoken as previously, this whole ability to basically predict these identifiers and these malicious IOPAs as soon to be malicious also allows the relevant businesses, those people who actually hold the legitimate assets to save a lot of time that is usually lost to them after the discovery of the exposed relevant subdomain, for example, or any relevant IOC that is weaponized. So being able to track and basically predict the attacker like over 2 months before their actually ability to activate these indicators is a huge advantage that allows us to basically save a lot of time for relevant business owners and many others.
We'll take questions at the end. The next thing that we simulated and wanted to show you is a little bit about our backend. We did a representation of what happens in the background, but basically this is, again, a representation of how it looks like on our backend continuously. This is part of the things that we do.
So if you remember, as we've spoken before, the attacker is able to send his basically attack results back to his personal email. Now, let's say that during the creation of the hijacked subdomain, basically when recreating the DNS management, the attacker makes a mistake and uses his own personal email to sign the SSL certificate used to create the hijacked subdomain. Now, we take this relevant subdomain that was hijacked as our initial IOC, as previously stated, which then becomes our initial hop point to be able to pivot from said IOC to the original C2 domain the attacker uses, as shown in the previous demonstration, to send the results to. We're able, based on this email that was shared across the two domain and subdomain certificate, to basically hop from one IOC to another, which is, as previously stated, the C2 domain. Now, using additional indicators that in this case can be the certificate, but can also be domains, IPs, and as Tal stated, additional indicators, we're able to pivot to additional C2 domains, which are, in this scenario, are the IOPAs, because the attacker is yet to activate them as actual IOCs. But we can see that these C2 domains are actually related to the attacker infrastructure, as they share the exact same certificate as the relevant C2 domain found connected to our subdomain from before. So as you can see, we have additional C2 domains here that are also related to like banking services and basically attack on the financial sector that are registered by the attacker but are yet to be used by him. And using this relevant pivoting and relevant clustering to create this malicious entity, we're in fact able to basically hold a map that shows the the visualization of all the relevant assets owned by said actor. So as you can see in this very screen, we have basically the relevant IOC we started from, which was, as previously stated, the hijacked subdomain. And using certificate pivoting in this example, we were able to reach our initial C2 domain that the attacker uses to send data to. And by pivoting on the C2 certificate, we're able to track additional IOPA domains, which are marked in orange, and point to, as previously stated, additional domains held by an attacker but are yet to be used by him. So using this, we're also able to create a very easy-to-see visualization for the users that shows him all the relevant threads. So if we can actually see using the demonstration, we can see that it allows the user to basically highlight the relevant threads. So this includes both the inserted IOC and the additional pivoting from it. The relevant mitigations in which our ability to both make sure that the subdomain, we change the relevant record of the DNS of the CNAME of the subdomain to point to a relevant and legitimate asset of the company so that the subdomain in fact won't be dangling and won't be able to be hijacked by an attacker anymore, while also be able to report to relevant services in order to take down and report basically these IOPAs and C2 domains and to make sure that the attacker and possibly additional victims won't be able to access them. Which also allows basically prevention of future attacks, as previously stated, in months ahead, and as previously shown, it can save a lot of time for relevant asset holders and many others.
Cool, and coming from the security industry, yes, a lot of security companies are doing this stuff, but it requires to get hold of the C2s. It requires to actually go and have the file and extract them and understand the behaviors. And from there, from the code, maybe understand where the rest of the infrastructure. We are doing that without that part. So everything that we are doing is based on open source information and a lot of correlation. And yeah, it's not, I will say AI, but it's mainly machine learning and classification techniques and all that.
So now let's dive deeper, in fact, into an alternate scenario of the attacker. Now, we assume that the attacker still wants to target a relevant financial sector bank like ours for the example. However, thanks to the mitigation that we've performed before by reporting on the relevant command and control domains, the IOPAs in this case, what happens here is a different scenario. Instead of the attacker being able to successfully create his hijacked asset, while he is able to, let's say, possibly find another exposed asset and take it over, he's unable to, in fact, create the phishing page using the AI agent. This is because his infrastructure is unable to connect to the relevant C2 domains. That's because, well, they've been taken down. And as you can see from here, when the AI agent tries to establish the connection between the hijacked subdomain, which is the phishing page, and the C2 domains, they all fail, the connections all fail together, and this causes an error to the AI attacker, and thus preventing and mitigating a possible exposure that could hurt tens of thousands of potential customers of the bank, as Tal previously stated, which is, again, very efficient and can also prevent mass-scale attacks in, well, mass scale.
Yeah, so part of our responsibility is sharing. We are planning out of stealth at the beginning of November, but this GitHub page is already up, and we decided to provide access to our data layer through APIs. So it's there. We are lazy, so there is no rate limit. It's based on fair use and the fact that we know who uses it. So if you want to use it, feel free, but over 1 million API calls, we will shoot you. I'm kidding. Sorry. So that's there. And what else I wanted to say? And that's it, I think. Any questions? Sure. We'll be around. Thank you very much again for the time and listening.
Thank you, guys.